Hey everyone, welcome back to the channel. Welcome to another video, and I'm really excited to see you all again. So let's continue our Linux journey. And of course, in this particular video, you're going to learn all about links. You're going to learn about hard links. You're going to learn about soft links. You're also going to learn about when is the right time to use hard links and soft links. And you're also going to learn some of the key differences between hard links and soft links. Remember, we're building on key concepts that we've learned in the past. So if this is the first time you're seeing this video, I encourage you to go take a look at the description and make sure you're up to date up until this point. It's very easy to get lost if you haven't seen some of the other videos and you're unfamiliar of some of the concepts that we use. So go check out the description, as it's always up to date with the latest information. If you learned something by the end of this video, make sure you give me a like for the video as it helps the channel grow. Don't forget to subscribe to the channel with notifications on so that way you're updated whenever we upload to the channel, and share the video with a family member or a friend. You never know, you could start off their tech career, or if they're in tech already, you can help them refine some of those skills. So with all the housekeeping out of the way, let's head to the desktop and let's learn all about links. Hey everyone, welcome to my desktop. And of course, we're here on the RHEL 8 desktop. As always, we are going to be building off of concepts and ideas that we've learned in the past. So if this is your first time coming to this video, go ahead and check the description, as there's a link to our playlist and you can get all caught up to where we are today. Because I will be honest, it will get very easy to get lost if you're not up to speed on what's been going on in prior videos. So with all of that stuff out of the way, let's learn about hard links and soft links for today. And by the way, this is a core fundamental skill in Linux, and understanding the differences between a hard link and a soft link and when you should use them is a concept that can greatly enhance your Linux file management skills. So let's go ahead and get started on it. Now, of course, in order to understand what hard links and soft links are, let's go ahead and launch the terminal first. Again, we go under activities and let's bring up our terminal. Let's make this a little bigger so everyone can see. So let's tackle hard links as our first link. And the first question you may have is, well, what is a hard link? In the Linux world, a hard link is an additional reference to an existing inode. Now, you know me, I love definitions. All right, clearly I don't. Who likes definitions, right? So now you may be wondering, well, what is an inode? So let's put hard links off to the side for a second and let's tackle what an inode is. And the command that we're going to work with today in order to figure out what an inode is the ls command. And remember, we're just building off of ideas and concepts that we've learned in the past. So the ls command shouldn't be a command that you're seeing for the first time. So let's take a look at what's inside our directory. And of course, we are in the home directory represented by the tilde. So let's go ahead and run ls. And as you can see here, we have some files. And we have some directories from prior examples. Now, the interesting thing is, if you read the man page, and I showed you how to do that in prior videos, but if you read the man page, you'll understand that you can use the -i flag in order to see what an inode is. So let's go ahead and run that. So here we have our same files and directories that were listed from before, except this time the inodes are included. Now, interestingly enough, an inode is a data structure that actually contains information about the file or the directory. These numbers that you see next to the directory, so as an example, we have 154 for desktop, 155 for documents. These numbers actually represent a place in the hard drive. So now that we understand what an inode is, how it's represented by these numbers, and all these numbers basically just represent a point in the hard drive, now we can go back to what a hard link is versus a soft link. And remember, we left off on the hard links. A hard link is a file on its own that represents an exact copy of the file that you're linking to. And funny enough, when you make that hard link, because it's an exact copy, you're going to see an inode number that represents the exact same file that you link to, specifically for a hard link. Now let's take a look at a quick example to see how this works. So here we have lewis.txt, as you see here in my directory, and it has an inode number of 8477192. Now, one of the ways in which we can make a link, and I'll show you both how to do a hard and a soft, but specifically for the hard link, is we use the ln command. And if we go real quick into the man page, you can see here it says make links between files and also as well directories. Now I expect for you guys to take a quick read on your own time for the man page. So let's exit out of here. So let's go ahead and create that hard link. And again, we're going to target the lewis.txt file. If you go ahead and read the manual, we'll do ln for the command. And remember, it's a three-part. So first part is the command itself. The second part is going to be the file in which we want to target. So remember, we're doing lewis.txt, which is the file that we want to target. And then the last part of the command is the name that we want to give that particular hard link. So let's go ahead and target lewis.txt, and let's call our hard link lewis underscore hard link .txt, and let's run that command and see what we get. So the command ran successfully. Let's go and take a look and see what we get when we actually created this hard link. So if we do an ls, we can actually see the hard link over here, and we can see the txt file over here. Remember, we forgot to add the -i flag to ls in order to see the inode. We want to see that the file is exactly the same, and the inode shows you that because it shows you where it is on the hard drive, and if it's the same file, then it should have the same inode number. So if we do an ls-i, we can see lewis.txt over here, and it has an inode number of 8477192. So here's our hard link, lewis underscore hardlink.txt. And what do you know? It has the same inode number, 8477192. Now remember, the inode number is just a structure of data that gives us the information about the file. And because it's an exact same replica of that file, you'll have the exact same inode number. Pretty cool. So let's also prove that theory a little bit further. Let's go ahead and use the cat command to show us what's inside lewis.txt. And of course, we've used this example before, but it says, hello, my name is Lewis. If the hard link is exactly the same as the original file, then we should be able to cat the hard link file, which in this case, lewis underscore hardlink.txt. We should get the same exact things. So let's go ahead and try that. And what do you know? Hello, my name is Lewis is the exact same output that we get. Now let's test this out a little bit further besides just catting it. Let's go ahead and use VI. We'll add some additional text and see if we get the same thing. So I'm going to open up VI, which is a text editor. I'm going to head over to lewis.txt, and I'm going to add learning about hard links. So let's go ahead and save that and quit. So now let's go ahead and cat the same file, lewis.txt. And of course you see, hello, my name is Lewis, learning about hard links. And let's go ahead and cat the hard link, and let's see if we get the same thing. Cat lewis underscore hard link. Hello, my name is Lewis, learning about hard links. Same exact output. And we know that, of course, because lewis.txt with an inode of 8477192 is the exact same inode as lewis underscore hardlink.txt. So effectively, a hard link behaves as two separate files, but these two separate files point to the same exact place on the hard drive, which is exactly why you see the same inode. Hey guys, quick pause. Hopefully you're enjoying the content. If you are enjoying the content, and you find that it provides value, make sure you go ahead and subscribe to the channel and turn on your notifications so you don't miss out when we upload to the channel. Make sure to give me a like for the video as it helps the channel grow. Share the video with a family member or friend so that way they can learn all about engineering, tech, and finances. Also, leave me a comment. Do you guys have any questions on what you learned so far? I would love to hear from you. So let's head back to the content. If you thought this was going to be a very, very difficult topic to understand and we were going to spend a lot of time on it, it really isn't. We are all done with understanding at a basic level what a hard link is. So at this point, let's tackle real quickly what a soft link is. Now, unlike a hard link where we're actually taking a point in the hard drive and we're making a file to point to that direct spot in the hard drive with the same exact inode, a soft link does not work in that manner. A soft link really just points to the file descriptor or the actual name of the file. It's really just a pointer in a sense. And if you ever worked in Windows and you've ever used a shortcut feature where you make a shortcut to a file or a directory, a soft link works very similar to that. It's really just a shortcut to the file. So now that you know what a soft link is from a basic terminology perspective, let's do an example so that way you can see how it differs from a hard link. And this time we're going to target the lewis.txt file as we did with the hard link, except this time we'll make a soft link. Same as a hard link, we use the ln command, except this time when you want to do a soft link, and you'll see this in the man page, you have to give it a dash lowercase s as a flag in order to represent a soft link. After the flag, let's go ahead and target the file that we are interested, and in this case it's lewis.txt, and we follow that up finally with the name of the soft link. So I'm going to name this soft link lewis underscore softlink.txt. And let's run that command and let's see what we get. So the command ran successfully. Let's do an ls-i in order to make sure that we list the inode number. From our previous example, here's the original file, lewis.txt. And as we said before, it has an inode number of 8477192. Here's our hard link, right? lewis_hardlink.txt with the same exact inode number as well. But here's the interesting thing. Here is our soft link. And our soft link has a different inode number because it's not an exact copy. And that's one of the main differences between a hard link and a soft link. A soft link doesn't have the same inode number because it's not an exact copy on the hard drive. It's basically another file, but it points to the original file. So here is another key difference between a hard link and a soft link. So I'm running the du command and with the -h flag, of course. And if you're unfamiliar with what the du command is, you can go to the man page and it tells you that it estimates the file space usage. So I'll give you time to read that on your own. So if we take a look and we understand now that the du command gives us the estimated file space on the hard drive, interestingly enough, because a hard link is the exact file structure with the same inode number that points to the hard drive, you can see that it matches the same amount of space. So if we look at lewis.txt, it has 4.0K. Same thing with lewis hard link, it also has 4.0K because it's the exact same. Now conversely, we just learned about the soft link. Here's one of the other major differences with the soft link. With the soft link, remember, it's just a pointer to the original file. The pointer doesn't take up anywhere near the same amount of space. This is another key difference because when you're working with files, let's say you're working with a large file and that file can be, let's just say 2 gigs. In a file that is 2 gigs in size, you may be better off creating a soft link, meaning a pointer to it, and putting that pointer anywhere that you need to in order to reference that 2 gig file. If you do a hard link in that particular case, you're basically creating another replica of the file. You're wasting 2 gigs of space on your hard drive. So that is a very key distinction of why you would want to use a hard link versus a soft link. So let's take a look at one more example of some of the key differences of hard links versus soft links. So if I go ahead and take a look at what's inside my soft link by using the cat command, you can see that it's the exact same as the hard link as well. So let's take a look at the hard link. Same thing, right? Hello, my name is Lewis, learning about hard links. And let's go ahead and cat the original file. So all of that seems to be the same. Let's add one more item to the list. Let's go ahead and add to our file, which is the lewis.txt. Let's go ahead and add to that file using the soft link in order to incorporate that we're also learning about soft links. So if I use vi, and let's head over to Lewis soft link. Now let's go ahead and copy, paste, and we'll replace this with saw. Let's go ahead and save that. So at this point now, let's cat all 3 of these files again, and let's see that we have what we need. So let's start off with soft link. Let's cat the hard link, and let's cat the original file. So now that we have those lines in there, because we wanted to make sure that we showed some love to the soft link, not just the hard link. Now let's say we get rid of our lewis.txt file. And remember, we did a hard link and a soft link that pointed to that lewis.txt file. So let's go ahead and remove that. So we got rid of the lewis.txt file. And if we do an ls again with the -i flag, lewis_hardlink.txt is still there, and it still has the same inode number. So here's that file. Here's the inode number. Lewis.txt doesn't exist anymore. And so if you've noticed, lewis_softlink.txt changed colors. So if we scroll up a little bit, you see here it is lewis_softlink.txt. It's blue, but over here it's red. So what does that mean? Well, let's cat the 2 files and see what we get. So let's start off with the hard link. We have, hello, my name is Lewis, learning about hard and soft links. Great. Let's go ahead and cat the soft link. And interestingly enough, we get an error for catting the soft link. And if you remember what the definition was, a soft link is basically a pointer back to the original file. And remember, because it's just a pointer, meaning it just points kind of like a shortcut, the file size is very small, which is one of the added benefits. But then the other problem that you have is if the original file gets removed, like in this case, your soft link now is broken. And that's exactly what this is telling us. Now, conversely, for a hard link, it's the exact same file size and it's the exact same file structure, which has the same inode number. The downside can be you are replicating the same files across the operating system, thus eating up more space in the hard drive. But one of the added benefits, as you see here, is if the original file gets removed, the hard link still works because it's the exact same copy of the file because it has the same structure and the exact same inode number. So really cool how soft links and hard links work. Now there's a few other scenarios in which hard links and soft links make sense. So now I'm going to leave it up to you guys to go ahead and take a look at when does it make sense to use a hard link versus a soft link, and go ahead and place your answers in the comments below so that way we can all know when to use a hard link versus when to use a soft link. So welcome back everyone. Up until this point, you should have all the information necessary in order to understand what links are, specifically hard link, soft link, what are some of the key differences between them, and when is a good time to use a hard link versus a soft link. During the video, I did mention that I didn't cover every single aspect in which you can use a hard link or a soft link. So it's up to you guys to figure out when should you use a hard link, when should you use a soft link. Go ahead and put that in the comments below so that way other people can understand when is the right time to use hard or soft link. Plus, I'm also curious too if you even did some of the work. So leave me a comment in the comment section below. So as a reminder, keep practicing. It does seem difficult at first because you may be learning this concept for the first time. So anything that is new for the first time always seems difficult, but with a little bit of practice, you'll be a pro. So I look forward to seeing you all in the next video. Make sure you give me a like for the video if it helped you out. Make sure you subscribe to the channel and turn on the notifications so that way you don't miss out whenever we upload to the channel. And of course, share the video with a family member or a friend. You could start off their career in engineering or tech, or if they're already in it, you could be helping them refine some of those skills. So I look forward to seeing you all in the next video.